Hi everyone, welcome back to Economics per se. Today we're at topic number 2 of the first chapter, which is going to be economic models, demand and supply. We'll be looking at some models, how to draw graphs, and a little bit of calculation. Well, most of us have played with Legos as kids. Using the right pieces, we build buildings and even towns. An economic model is just like that, without the danger of stepping on one. Economists build models to represent the real economy as closely as possible. These models will help us determine the relationship between two or more variables. For example, this model, where real GDP is considered equal to A, inflation, and B, unemployment. Here, it shows us the relationship between real GDP, inflation, and unemployment. Here, A signifies by how much real GDP changes with 1% change in inflation while unemployment is constant, and B shows by how much real GDP changes with 1% change in the unemployment rate while the inflation is held constant. Now, to make the idea of models absolutely clear, let us use the most famous model of all, the supply and demand model. Say you want to figure out what determines the price of hamburgers and the number of hamburgers sold in the market. You will have to build a model that would describe the actions of a buyer and a seller and how they would interact with each other. Now, building a simple model, let's say the quantity demanded of hamburgers depends on its price and aggregate income. So to write the model, it would be something like QT is equal to P and Y. Here, QT is quantity demanded, Y is the income, and P is the price. D parentheses, it represents the demand function. Just like that, let's suppose that the quantity supplied of hamburgers depends on its price and the price of other materials used to make it, like buns and meat and condiments. So, quantity supply would be equal to S parentheses P and PM. Here, QS represents quantity supplied, P is the price, and PM is price of materials used. S parentheses again represents the supply function. Finally, we have to assume that the price of hamburgers adjusts in the market to bring quantity supplied equal to quantity demanded. We'll call this equilibrium. We can represent this by setting quantity demanded as equal to quantity supplied. It's important, well, first of all, these three models are what will compose of our market for hamburgers in a simplified way. It's important for us as economists to illustrate the model with the help of a diagram. So now let's try to draw a diagram. Let's do it here. So we have the y-axis, which is going to represent the price of the hamburgers. We have the x-axis, which is going to represent the quantity supplied and the quantity demanded of hamburgers. The demand curve will show the relationship between the price of hamburgers and the quantity demanded of it, holding income constant. The demand curve will slope downwards from left to right. Now, the demand curve slopes from left to right downwards because a higher price of burgers will encourage buyers to switch to other alternatives like pizzas or burritos, and it will decrease the quantity demanded of the burgers. Higher price, lower quantity. The supply, let me label this T1. The supply curve shows the relationship between the price of the burgers and the quantity supplied of it, holding prices of raw materials constant. The supply curve will slope upwards from left to right because higher prices will lead to higher profits for producers, so they will try to produce more. So again, left to right, going upwards, this is S1. The equilibrium point in the market is at the price and the quantity at which the supply and the demand curves intersect. We call this the market clearing price and quantity. Here the buyers will buy the number of burgers produced by the sellers, and everything is equalized. We represent this with the red. This is going to be Q1, equilibrium point 1, and this is price 1. Things to remember here are the laws of supply and demand, which is higher the price, lower the demand, lower the price, higher the demand. And for supply, it's higher the price, higher the supply, lower the price, lower the supply. Another important thing to remember is the concept of ceteris paribus, meaning holding other factors constant. We said earlier that demand curves show the relationship between price and quantity demanded, holding aggregate income constant. We're assuming ceteris paribus. Same thing when we held prices of raw material constant when we were talking about the supply curve. So our model of the market of hamburgers had two endogenous variables and two exogenous variables. Endogenous variables are variables that directly affect the model, and the exogenous variables are variables that indirectly affect the model. In our function for demand and supply, prices were the endogenous variables, and aggregate income, Y, was the exogenous variable for the demand function, and the prices of the raw materials or materials used to make burgers were the exogenous variables to represent the supply. We see that the movement along the supply and the demand curve depends on the adjusting of the price of burgers in our market. We discussed that earlier. But our model can also be used to show how certain changes in our exogenous variables, like the aggregate income and the price of raw materials, can affect both price and quantity as well. So, if aggregate income increases, the demand for burgers will increase, because now the consumers can afford to buy more burgers. This is represented by a rightward shift in the demand curve. So the demand curve will shift to the right, going from D1 to D2. With this, the market will move to a new equilibrium point from E1 to E2. Prices will go up to B2, and the quantity will change to Q2. Now, another scenario: if the prices of the materials to make the burgers increases, that means that making burgers are getting expensive for producers. So the producers will decrease the supply, represented by a leftward shift in the supply curve. The supply curve shifts to the left from S1 to S2. This will change the equilibrium point from E1 here to E2 again, and the new price, P1 here, P2 I mean, and Q2. Now, that was a simple model we created for the market for hamburgers, but you should remember that this is a very simplified model. There are many more factors we would have to take into account for a more accurate study. Factors like location of the burger store and the fact that different burgers are priced differently are all considerations you have to make. The number of considerations you need to make depends on the question you're trying to answer. For example, if you're trying to figure out how the prices of buns would affect the market for burgers, a model like this might work for you. But if you want to compare prices of burgers in different locations, this model wouldn't be too helpful. Having said that, the simpler the model, the better. So now we're just going to try to solve a problem, trying to figure out what the market clearing price and quantity would be if we had the demand and the supply functions given. So first of all, demand has negative price associated with it because demand increases when price decreases, and as income increases, demand increases as well. Here, supply increases when price increases, so it's a positive sign here, and when the price of materials decreases, supply increases, so there's a negative sign right here. So the quantity demand is going to equal to 10 minus 2p plus y, which is 6, giving us 16 minus 2p. This is the quantity demanded. and supply will be the same step, 5 plus 3p minus em, which is 3, which would give us 2 plus 3p. Now at equilibrium, we have to set quantity demanded as equal to quantity supplied. So let's say at E being equilibrium, we set quantity demanded equal to quantity supplied. Doing that here, we have 16 minus 2p, setting that equal to this, which is 2 plus 3p. Taking 2 to the other side, we have 16 minus 2, which is 14, which would equal to, taking this to the other side, 5p. So, continue this right here. 14 divided by 5 would be 2.8, which is equal to our p star. This is going to be the market clearing price. This is not the price coming from, this is not the demand functions price or the supply functions price. It's the price from both of them together. So now since we have the market clearing price, we can just put this value into either one of these functions. Let's pick the supply. So we'll say QS, which was equal to 2 plus 3p. Now p now, we know that it's equal to 2.8, which is equal to 2 plus 3 times 2.8, which is going to equal, what is 3 times 2.8, Tom?
8.4.
8.4. 10.4 is going to be our Q star. Again, this is the market clearing quantity, not the quantity demanded or the supplied. So if we were to draw a graph, start hypothetical one here, this would be price, this would be quantity, this is supply and demand. This point here would be equilibrium, and this quantity is right here, 10.4, and the price is right here, 2.8, supply and demand. I hope you like that video. It'd be great if you could like and subscribe to our channel. See you next time. Thank you.